In today's video, we're going to be talking about functional equations. Basically, it's an equation with a function and you have to solve for the function. So in this case, we have x plus f of x is equal to x times f of x. This is actually very easy. You can use a quick factoring trick, but it will get harder. The third one isn't on here. That'll take up like the whole board. So this first one's very easy. That's why I don't have a lot of space for it. So essentially we can move this f of x to the other side. We can say that x is equal to, we can do x times f of x minus f of x, right? And it's okay if we have like x's and stuff. All we have to do is just kind of make sure that f of x is by itself. So now we can just factor f of x out, so x is equal to f of x, but this is multiplied by x minus 1. Now note that these parentheses don't mean that it's like f of x minus 1, it just means it's f of x times the quantity x minus 1. So we just divide both sides by x minus 1, and we can say that x divided by x minus 1 is equal to f of x. And you can check if it satisfies. So you could say, okay, well, x plus x over x minus 1, is that equal to x times x minus x over x minus 1? And you'll see that that is true. So that was pretty easy. How about x times f of x equals x to the f of x power? See, this is a lot more difficult, and you know, we can use some cool tricks to help us out. Now, one thing I want to notice is this. You're not going to be able to like do this with like basic algebra knowledge. You have to introduce another equation, the Lambert W function, which I'll probably make a video about this at some point. Actually, I think I have made a video with this, where basically, let's say the input is t, so w of t times e to the t is going to be t. So that's something we should know. And basically if we get it in this form, where we have like t, like we could say like f of x times e to the f of x, if we get it in some form like that, we can just spit out an f of x, as long as we take the w of both sides. This is kind of the natural log. It's actually called the product logarithm, so it is a type of log. So basically we can use that to help us, so we can kind of just move all the f of x's to the same side. I'm going to actually divide by f of x on both sides, so we get that x is equal to 1 over f of x times x to the f of x. Okay, well, what can we do now? Well, what we can do is we could just say that this is e to the f of x times ln x. So you can see like x is equal to 1 over f of x times e to the f of x ln x. Okay, well, how does that help? Well, we have the e now. We have the f of x there and the f of x there also. So this is actually really good for us because we're starting to actually like be able to do this. This is an f of x to the negative 1 power. I can actually just rewrite that here. This is f of x to the negative 1 times e to the f of x ln x. So how would we fix that? Well, we could take the negative 1 power on all sides, well, all two sides, and you can see that that's going to really help. So we get x to the negative 1 equals, well, this f of x to the negative 1 to the negative 1, that's just going to cancel out. That's kind of the whole reason why we're doing this. And then we also have to multiply this, like raise that to the negative 1 power. That's just going to make this e to the negative f of x ln x. So you can see that we did, like this helps us a lot because now we don't have the weird denominator thing. And now what we can do is you can see, well, it's almost in kind of this form where we have like our t being this. So now this is our desired t. I'm not going to actually write on it. But our t is going to be negative f of x times ln x, so we just have to make this the same thing. Well, this is actually really good because all we have to do is multiply both sides by negative ln x, because I mean, if we have ln x's and stuff, that's okay. So we can just say this is x to negative 1, and of course we apply our negative, times ln x is equal to negative, right? And then we have our f of x from there, and we're multiplying by ln x. So we'll just put it times ln x. Actually, then this is times e to the negative f of x times ln x. And this is t times e to the t. So we can take the w of both sides. Let me give myself some space. We can take the w of both sides, and then we see that w of this is just 1 over x. So we get negative ln x over x. We can just do it that way. Is equal to, well, w of t times e to the t is just going to give us t. So we have negative f of x times ln x. And the easy way to do this is we can just divide by a negative ln x. So we get that this is equal to, so I can put f of x over here. F of x is equal to negative 1 over ln x. Hold on, 1 over ln x times our w of negative ln x over x. And this is our solution to this equation using the Lambert W function. And that's really, really good for us. So what's problem 3 going to be if this is, this was pretty hard, so we'll see what number 3 is. This is number 3, and it, pretty much looks like everything else. Like, what's the difference? The difference is this plus and the exponent here. Well, again, it's still like the same. Well, what makes this much more challenging is because all the other ones we were working with were in some form like, okay, well, we had addition equal to multiplication, and then we had multiplication equal to exponentiation. So they're kind of, like, this was super easy because, we have basic rules between addition and multiplication. This was, it was a little challenging. I mean, we had to use some higher level algebra. But we're now going straight from addition to exponentiation. And that's really difficult. We have ways to do it, but it's just going to be very challenging for us. So that's why it's probably going to take up the whole board. Another thing is I'm going to refer to my f of x as just f. So I'm going to write here, I'll just write it down here. I'll say x plus f is equal to x times f. And I'm going to say that f, that's not a great f. F equals f of x, alright? Because, having all those f of x's everywhere, it kind of gets a little cluttering. So just x plus f equals x to the f. You can think of f as y if you're more comfortable with that. But yeah, so all we have to do is isolate the f. Sounds easy. Easier said than done. So x plus f equals x times f. The first thing you kind of want to do is probably isolate, or not really isolate, but move all the f's on both sides. So you can say that x is equal to x to the f minus f. So now our f's are on the same side. We can start manipulating them. You can kind of make the observation that this is like, well, x to the f is e to the f ln x, right? Using that trick that we used in the last one. And this is, really just f. For now, we can keep it. And if we raise both sides to the e power, we can say that e to the x is equal to e to the f ln x minus, minus f. Well, what good does this do us? Well, now we can turn this subtraction into a kind of division. So I'll show you what I mean. So we get that e to the x is equal to e to the f ln x times, e times e to the negative f. I don't want to make that on the same line there. Let me just make it e to the negative f. So, same line here. So what we're doing now is we're kind of converting into that multiplication to kind of help us to put it in some sort of form. And you can see, well, we have this e to the e, but we have an e here and an e here. So what if we kind of just change the order of this multiplication, which we can definitely do. E to the negative f times e to the f ln x. Okay, I mean, what's this doing for us? Well, this is good because we have like, we can pretend like this is our t times e to the t, because we have the e there and the e there, so it's kind of the same. So that's kind of what we're going to try to do. We're going to try to make this and that the same. And it's like, oh, we just do a few steps, but we're still like really not close to being done. So, let's see, well, what can we do? Well, we could raise both sides to the ln x power. You can see here, if we do that, we get that e to the x ln x is equal to e to the negative f ln x times e to the, we also have to raise that part to the ln x. We get e to the f ln x ln x. So, you know, it kind of created a complication here. Let me just put that on the same line. It created a little complication there, but that's really not hard because that's kind of on the same like line there. So if we just multiply now both sides by ln x, we can see that we get e to the x ln x is just x to the x, because e to the ln x cancels, you know, so that just gives us x to the x is equal to, now we can just multiply, and actually we're multiplying by ln x is equal to e to the negative f ln x times our ln x. And then we're also multiplying by e to the f ln x, right? So, okay, well, what do we have? So we have e to the negative f ln x times ln x. This is our, like, t. We have e to the f ln x. This is really close to that. We're just offset by a negative. So let me bring this up here. So we're just offset by this negative, which is actually kind of bad because it's really hard to put a negative up there on the third level. Like, you can easily put it on the second level. So what can we do? Well, we can get rid of this negative. We can totally do that. All we have to do is just raise both sides to the negative 1 power. So we're going to have to do this. We have we have x to the negative x. Okay, and then we have this ln x to the negative 1 power also. Alright, and that's going to be equal to e negative times the negative is positive, so that's going to be e to the f ln x. And actually, before I proceed, you can notice e to the f ln x is just going to be x to the f. So that's a nice little simplification, and we're still multiplying by that ln x, but this ln x is also being raised to the negative 1 power. So we have to keep note of that. And then this whole thing is going to be raised to the negative 1 power. So we get that e to the negative e to the f ln x times ln x. Actually, again, also we can say that this is just x to the f, negative x to the f, just to help simplify things. And we're still multiplying by the ln x. Let me make that f like over here. All right. Okay. So, well, does this really help us? Well, we have this like we have this ln x to the negative 1 power. Like, that's really not helping us. So why don't we just multiply both sides by ln x, or ln squared x? Because look, we can say that x to the negative x. Multiply this by ln x to the second power. Negative 1 plus 2 is 1, so we have this ln x is equal to x to the f times ln x, basically the same thing as we did there. And we only have to multiply once here, so negative x f ln x. That stays the same as that. Okay, well, what do we have? X to the f ln x, negative x to the f ln x. Still have the negative. Like, that's what we've been dealing with for a while. But this is a lot better to have here than it is to have down here, because, why? Because look, all we have to do is put a negative there. And it's the same thing. But wait, we have to make sure that this negative, you know, whatever we do to that side, we have to do to the other. So we have that negative there. These two are the same thing. We finally put it in the same form. So now all I have to do, I'm going to actually rewrite this. We have w of negative x to the negative x ln x is equal to, and if we take the w on this side, remember, we're just going to get the negative x to the f ln x. without, the rest of it. Now we just have to isolate f of x. All we have to do is divide by ln x. So actually I can just do it very easily like this by just doing divided by ln x. Also we can divide by that -1. All we gotta do now is we could just take the natural log, and then we'll have like x ln f whatever, or f whatever. But if we just take the log base x on both sides, that's gonna be really helpful for us. So I'm gonna say that f of x, because log base x of x to the f is just gonna give us f back. So log base x of -w of -x to -x ln x, all of that divided by ln x. Now, you may be like, oh, well, it's log of a negative, that's weird. In certain cases, that would give you a real number, but in most cases, most instances of x, it'll probably give you a complex number, which is okay. There's nothing wrong with complex numbers. But yeah, you can argue with that, but like that's the result I got. It's a really complicated equation, so it's really easy to make some mistakes here and there, but this is the result I got for this crazy functional equation. So you can see that going from multiplication to addition is really easy. Multiplication to exponentiation is kind of like, okay, and then addition to exponentiation is just like you get this expression. Like how much crazier can it get? Well, it could get a lot crazier. But yeah, this video's been going on for long enough, so hopefully you enjoyed. I'd like to do more of these functional equations in the future, and so yeah. Thanks for watching, and I'll see you in the next episode. Bye.